Hello all. In this video, we'll learn about reinforcement learning algorithm. So what is reinforcement learning? Reinforcement learning actually focuses on how the agents can learn to make decisions through trial and error to maximize the cumulative rewards. So actually, the reinforcement learning allows machines to learn by interacting with an environment, and it receives feedback based on the actions whatever they have performed. The feedback whatever they get is in the form of rewards or penalties. That is, it means that the reinforcement learning revolves around the idea that an agent interacts with an environment to achieve its goal. The agent performs certain actions and receives some feedback to optimize its decision making over the time. So what are the components we have with reinforcement learning? That is agent, environment, state, action and award. We'll see all these things using a diagram. So here we have an agent. This agent, consider it as an AA agent. Then we have an environment. Environment can be any environment. For example, in FDP, we have seen an environment which is like a cell environment where the agent will be starting from the starting cell 1, 1 and it can move around the cell, and in between we'll have the pit, or it can reach a treasure, or the agent can reach a fire. So the environment can be any environment. In real world, for example, it can be a self-driving car environment. So now the AI agent can perform certain actions in the environment. When we do certain actions in the environment, the agent can move from one position to another position. So initially in the cell, initially the agent will be in 1, 1, and after performing some action, the agent can move to, for example, if it does upward move, then it can move to another cell, and it can be said to be a state. So it is 2, 1. The agent moves from one cell to another cell. So it means that it moves from one state to another state. When the agent moves from one state to another state, based on the action it performs, it may get a reward. The reward can be a positive reward or it can be a negative reward. The negative reward can be named as a penalty. So now we know what is an agent. An agent is a decision maker which performs certain actions. The actions can be, for example, in the cell world, it can be up, down, right, left, and so on. Environment in which the action the agent moves upon. And what is the state? State is, in the environment there will be certain state. For example, 1, 1, 2, 1 and so on. The reward is the feedback or result from the environment based on the agent's action. Now we'll learn what are the core components of reinforcement learning. The core components of reinforcement learning are policy, the reward, the value function, and the model. We'll look into all these things one by one. First one is policy. Policy can be defined in terms of MDP, that is Markov decision process. Already we have seen a Markov decision process, and I will be giving the Markov decision process link in the description. Those who haven't checked, you can go through the video. So the policy defines the agent's behavior, that is, it maps the states for actions. The policy can be simple rules or it can be complex computations. Therefore, a policy is defined as a strategy that an agent uses in pursuit of goals. The policy dictates the actions that the agent takes as a function of the agent's state and the environment. For example, in an autonomous car, it maps the pedestrian detection to make the necessary stops. The policy can be either deterministic policy or stochastic policy. Already we have discussed in MDP. Now we'll see an example for policy. Consider a practical scenario. Here, the agent has to search the food from the environment in order to satisfy its hunger. Then it receives a reward on the basis of the fruit whatever it eats. So here we have the agent in the cell 1, 1 and there are two fruits, pear and apple. The agent will be receiving a negative reward of -1 when it moves from one cell to another cell where there are no fruit. Consider if the agent moves from 1, 1 to 1, 2, then it gets a reward of -1 as there is no fruit in this cell. If the agent moves to a cell which has pear, then it gets a reward of +5. And if the agent moves to the apple, then the agent gets a reward of +10. So for example, this is the scenario we have. Okay, so now you know what is the reward. Moving between the cells where there is no fruit, then the reward is -1. If there is a pear, then the reward is +5. If there is an apple, then the reward is +10. Now we need to find the policy. So how to find the policy? So there are two policies. One is the agent moves from the first cell, that is 1, 1 to the pear cell, and another policy we have is it moves from the starting position to the cell where the apple is. So what actions it has to do in the first policy, pi 1, the actions the agent needs to do are downwards, rightwards and then rightwards. Okay, so there are 3 moves. Similarly, in second policy, the agent has to do certain moves. The first one is right move, right move, right move, and then down move, and last down move to get to reach the apple. So totally there are 6 moves. Now, how to calculate the best policy? There are 2 policies. We need to identify the best policy. So how to identify the best policy? We'll identify the best policy based on the reward. So here the reward value is given. Okay. So already we have seen the reward as -1 when the agent moves between non-fruit cell, and if the agent reaches the pear, then the reward will be +5. If the agent reaches an apple, the reward will be +10. So based on this, we can find the policy. So utility value, that is u pi 1 is equal to -1 and +5. So it is, we have seen a downward, right. So here it is -1 and it reaches the pair, so it is +5. When we totally add it, we get a value of +3. Similarly, for the second policy, it's -1, then it is a downward, it is -1, and here it is reaching an apple, so it is +10. So it is +10 here, you can see -1, +10. So when we add all these things totally, we get +5. So which policy is the best policy? The second policy is the best policy. The next one is reward. The reward function provides immediate feedback by assigning a numerical value to each action taken by the particular agent. So in the previous example also we have seen. Here the agent learns to perform actions that result in higher rewards by exploring various actions, state pairs, and update its policies. So in the previous example also we have seen that the rewards will be added, and whatever maximum reward at the end we are getting, we are choosing it. Okay. So here also in this example, so -1 here the values are written. So what we will be doing? The maximum value, whatever maximum value we are getting, that reward or that particular thing will be selecting. Okay. What are the different types of rewards? A positive reward and the negative reward are penalty. So what is a positive reward? It should be given when the agent takes actions that bring it closer to the goal. When it is closer to the goal, then we'll get a positive reward. So it is here, you can see it's very closer to the goal and it is getting a positive reward as +1. And then negative reward. So what is actually a negative reward? It is a discourage for the agent from taking to take the incorrect actions. So for example, in the car simulation, negative rewards will be given when there is a collision or driving away from the road. So this is all about reward. The next one is value function. So value function in detail already we have seen in MDP. The link is given in the description. You can go through it. So in brief, we'll see what is the value function. A value function gives information about how good the current situation and the action are and how much reward the agent will be getting. Okay, so this is said to be a value function. And basically the reward will indicate the immediate signal for each good and bad action, whereas the value function specifies the good state and the action for the future. The value function depends on the reward, as without reward there could be no value. So actually the value function will always depend on the reward. The goal of estimating values is to achieve more reward. The higher the reward, the higher you are nearby to the goal. So there are different types of value function. One is state value function, then action value function, and then in optimal value function. In optimal value function, we have optimal state value function and optimal action value function. Then we'll see what are all the approaches we follow in reinforcement learning. The first approach is value-based approach, the next one policy-based approach, model-based approach, and hybrid-based approach. We'll look into one after another. What is value-based approach? In a value-based method, we try to maximize the value function V of S. In this approach, the agent can be dreamt of a long-term return at any state under policy pi at any state. The next one is policy-based approach. In policy-based approach, we focus on choosing the best policy in which the performed action in every state maximize the reward in the future, as we have seen in the previous example. There are different types of policies. One is deterministic policy and another one is stochastic policy. The next one is model-based approach. In model-based approach, we'd like to create a virtual model for each environment, and the agent will be trying to learn for every specific environment. So this is said to be model-based approach. And the last one is hybrid approaches. This combines the best of both policy-based approach as well as value-based reinforcement learning. Next one is what are the types of reinforcement learning. The different types of reinforcement learning are passive reinforcement learning and active reinforcement learning. What is passive reinforcement learning? The agent actually follows the fixed policy. Always the agent will be following the given fixed policy. The policy will be fixed by an expert or the subject expert. In perceived learning, it attempts to evaluate the policy pi without the knowledge of the reward function as well as the transition model. So it means that in passive reinforcement learning, it does not know about the reward value as well as the transition model value, that the likelihood probability value. This is usually done by some method of utility estimation. That is, the first method we have is direct utility estimation, adaptive dynamic programming method, and then temporal difference learning method. These are all the different types of passive reinforcement learning. The next one is active reinforcement learning. Unlike passive reinforcement learning, in active reinforcement learning, We are not bound by a policy pi, and we need to select our actions. In other words, the agent needs to learn an optimal policy on the go. That is, the fundamental trade-off between the agent needs to face is that of exploration versus exploitation. An example algorithm for active reinforcement learning is Q-learning agent. This is all about the basis of reinforcement learning, and in the next video we'll learn what is passive reinforcement learning and active reinforcement learning. Thank you all.